Hello everyone, welcome back. In today's video we're going to see Slab strip in Protastructure 2024. Strips are used to analyze and in analysis and design of slab in Protastructure. After modeling, if after you have modeled your model, you have to use the strip in order to analyze and design your slabs. Using strips, the slab is analyzed and designed, providing the enforcement, diameter, and the spacing. Okay. So, in order to start, I will highlight that before starting modeling your strips, you have to make sure that you have completed your analysis. You see, mine are already completed, are updated, and the grading analysis and the finite flow analysis are updated. So I can move on and start modeling or drawing the straps. The strips. Strips are found in modeling tab. And RSC member, there is slab strips. Okay. If I click on slab strips, the strips properties will appear here at the right. See this box? So we are going to see all the parameters or the properties that are found in the strips properties. Starting here, there is a slab label, the strip label, the strip type, the boundary condition, slab width, and the scope width in general tabs. So here at the right, there is another tab called the bar tabs, or even manually tabs, and we are going to pass through it as well. So let's start with exploring each and every strip. Then after, we'll try to draw different type of strips. Here I have tried to show you or to differentiate all different types of strips. In Protastructure, we have 3 types of strips. Okay, the types. There are analytical strip, a finite element strip, and the manual strips. If you come in the software, you can see in the type property, there are 3 different types: the analytical strip, the finite element strip, or in abbreviation say FE strips, and the manual strips. Okay. So here at the left, it's the properties for the analytical strip. At the middle, the properties of finite element strips, and at the right, there is properties of the manual strips. So if you check well, the first one is called here it's a strip label, not a slab label. Okay. In all the 3 types of strip, there is they all have the property called strip label. This is strip label, not slab label. So the first one is the direction. The direction. So the one which is horizontal, it is in X direction. With the one which is vertical, it is the Y direction. So it's up to you to determine and to choose whether the strip we are going to draw is in X direction if it is horizontal, and Y direction if it is vertical, it is in Y direction. So here the number, it is the numbering. So the first strip will be 1, the second one will be numbered as 2, the third one as 3, and so on. So it is the same for the analytical, finite element, and the manual strip. This is the first property called strip label. The second one is called strip type, the one in orange color, strip type. So if you have chosen the analytical strip, it is this case, this first case. If you have chosen the finite element strip, there will be additional information that will pop up. These two icons and the one in yellow will be going through in details in a while. And if you choose the manual strip, then you will have a manual tab, a manual tab here. But in Protastructure 2024, it was renamed not manual. It is called the steel rebars. Let me show you. You see here, if I click on manual strip, this bar was renamed as steel bars, not manual as shown on the picture. Okay, but the content it's still the same. Okay. Then another property here at the bottom, it is called the boundary conditions. Boundary conditions are the boundary condition of the slab you are working on. Okay, not the strip but the slab. There is a boundary condition at the start and at the end. At the start, it means where you are starting your strip, and at the end, it is where you are ending your strip. If it is in X direction, drawing from left to right, so at the start will be the first click at the left, then the end condition will be the second click at the right hand. Okay. So please highlight that in Protastructure, a better way to draw strips is always from the left to the right in X direction, and from the bottom to the top in Y direction. Okay. So the boundary conditions, there are three types of boundary conditions. The first one, it is called the continuous. Right? It means the slab are continuous at the start or at the end. The second one, it is called the end. It means there is a support at the start or at the end of your slab. And the last one, the third one, it is called cantilever, meaning that you have a cantilever either at the start or at the end of the strip. Okay, so it is same for the two types of slab. I mean analytical strip and the finite element strip. Okay, because the boundary condition doesn't work for the manual strip. It is only for the an analytical and the finite element strip. Because if you check well here in the manual strip, it is somehow deactivated. Okay. Another property, it is called the slab width. Slab width. Slab width is used just to control the extensions of top steel bars. Okay, only for the case where you have a continuous slab. If you have a continuous slab and you have to control the extension of the top steel bars, okay, you may use the slab width. In other words, the slab width only works if the boundary conditions are continuous. Just only if the boundary conditions are continuous, then the slab width will be activated. Otherwise, it will not be active. Okay. If you have, if you have a boundary condition which is end or cantilever, the slab width will be deactivated. As you can see here, we have end conditions. The slab width will be deactivated. Let me show you in software. Let's say I have choose the analytical strip. You see the slab width is deactivated, but if I click on continuous boundary condition, then you see at the start it is now activated. At the end, if I choose the boundary condition to be continuous, then the slab width will be activated at the end. So the slab width only works if we have boundary condition which is continuous only. If I have either end conditions or cantilever conditions, here they are not active. Okay, that's what I mean by saying that slab width only work with the bounded condition which is continuous. So coming back to our slab properties, I mean strip properties. So there is another, the last property, which is called scope width. You see, a scope width. As you can realize here, in all the three types, the scope width is deactivated. It means the scope width, first of all, what is the scope width, or what is the purpose of the scope width? The scope width help us to determine the width of the strip, of the band strip. Okay, let me show in a software so that you can understand more. Here the scope width is deactivated because it is analytical strip. Scope width only works with the finite element strip, with fixed band strip activated. In a finite element strip, there are two types: the span strip, this one, and the second one, which is the fixed band strip. So the span strip is only used when the slab have the support at the end, or in other words, if there are beams, it is supported by beams. So if you choose to use the finite strip, you will be using the span strip. Okay. So if you choose to use fixed band strip, then it means you have a slab which is not bounded by beams. In other words, if you have a flat slab, in that case you will be using the fixed band, right? So the scope width is only activated if you have chosen the finite element strip with fixed band. Okay. So if I try to draw quickly this strip, let me zoom in. Okay, you see there is like a center line of the strip and the boundaries. So it means the analysis and design of this slab will only be done in the area which is bounded by this strip. Okay, so the scope width is used to control this width of the slab of the strip. So as you can see here at the left and at the right, we have 1 meter. It means here at the top, at the left, we have 1 meter, and at the bottom, which is right, we have 1 meter. If I try to put, for instance, 2 meter and click on update, then now we see that in update to 2 meter. The same, I can even here update to 2 meter. If 2 meter is 2000 mm, okay, then it is updated. Okay, you can also update this boundary by using this arrow. If I click on this arrow here and click on a certain point, for instance here, and click on update, automatically the boundary will be updated up to that point. Okay. The same is applicable for the right part. If I click, for instance, this point, click on update, then the boundary will be updated. So it means in this case, the analysis and design of this slab will be designed according to the boundary of this finite element strip. Okay, let me put it again 1 meter. And then update. You see, to see the change of what you are changing. For instance, to see the change, you have to always click on update. See, before, after changing the values, you have to update in order to see the change. Okay. So this is the scope width. So that's all for the general tab. That's all you can know about the general tab. Then coming to the steel bar tabs or the manual tab. Okay. In order to use it, you must make sure that here you have choose the manual strip. Right. If you have chosen the manual strip, then the steel bar will be updated. Okay. So you can choose either if you want to use the top steel and the bottom steel, check or uncheck what you want to use, and then define all the parameters if you want to use the bulbs, the left extension, the right extension, the quantity of steel bars, the diameter of steel bar, even the spacing. After filling all the information, then you can draw the strip. Okay. Yeah, that's all for the properties of the strips. Okay. So as a recap, we have seen the strip labels, the strip types, the boundary condition, what is slab width, and what is scope width. Now, when do we use analytical strip? When do we use finite strip? And when do we use the manual strip? The analytical strip is used when you want the slab rebar design to be based on the building analysis result. Okay. The finite element strip are used when you want that the software have to consider the slab rebar design based on the finite element analysis. In finite element analysis, there is building analysis, and the source may be the building analysis or the finite element flow analysis. Okay, I'll show you in a while in the software. Okay. Then the manual strip are used when the user, the designer, want to manually manipulate the steel rebars that will be put in the slab. Okay. It means that the slab rebar design will not be based on the analysis and design of the software. So the user have to put the steel rebars manually. Those are the three different type of slab strip and when to use them. So in analysis, there are building analysis and finite element flow analysis. Okay. So if you have used a building analysis here, then the type of slab to be of strip to be used will be analytical strips. Okay, because you want that the software calculate the slab rebars based on the building analysis result or the moment coefficient method. Okay, but if you have performed the finite element flow analysis, if you have used it, so the type of strip to be used will be the finite element strip. Okay, if you choose the finite element strip, you have to choose either the span strip or the band strip or fixed band strip according to the boundaries or the supports of your slab. Okay, after choosing which one to be used, you have to choose the analysis result source. So there are two types. Either the source may come from the building analysis or the source may come from the finite element flow analysis. The building analysis must be checked if and only if you have checked in analysis, the type of analysis you have used in Slab model. If you have used the finite element mesh, if you have used the finite element mesh, it means this is active. You have set all the slab stiffness and all the parameters, the shell element size. If this finite element mesh was used during analysis, then in the slab you have to check this building analysis, because the source, the analysis result source will come from that building analysis that I've shown you. So if in analysis you have used the finite element flow analysis, so you in that case you must check the finite element flow analysis as the source, okay? Because the software must consider the analysis result of the finite element flow analysis, because it is the one that you have used. So pay attention to know which one to choose according to the analysis that you have performed. And lastly, for the manual strip, you have to it's up to you as a designer to manipulate all the information. So that's it. We have now we now know the different type of strip. Okay, there are three: analytical, finite element, and manual. Analytical, which is used when you want to the slab to be designed according to the building analysis result or the moment coefficient. Okay, the finite element strip, which is used when you want that the design, if you want the design to be based on the finite element flow analysis or the building analysis flow meshing that comes from the building analysis. Okay, and the manual strip, when the user wants to manually manipulate the story bars. Those are the three types. So let's try to see how then how to model or to draw the strips. We will draw an analytical strip, a finite element strip, and the manual strip. Okay, let's start by analytical strip. So remember, in order to draw the strip, you must first check that your analysis are updated. Okay, that's the first thing. The second thing, you have to remember that if modeling the strip, the x direction will always be the horizontal strip, and the y direction will always be the vertical strips. Okay, the third tips to remember is that you have always to draw the x direction strip from the left to the right. Okay, and the y direction strip must be drawn from the left, from the top, from the bottom to the top. Okay, yeah, then let's start drawing the analytical strip. You have to come in the modeling, slab strip. You have to check the label. It will be labeled as the direction will be the x direction. Right. Let's for instance focus on the slab in the middle here. Okay. Let's suppose we are going to draw the strip for this slab in the middle. Okay. Strip label will be in x direction, because we are going to draw the horizontal strip. Okay. The type will be analytical. The boundary condition, remember the boundary condition is for the slab. Okay. We will be starting from the left to the right. So the boundary condition of this slab at the left, at the start, is continuous, because this slab, you see that it is continuous. So I will choose continuous. Okay. Then the boundary condition of this slab at the end, which is the right, is also continuous. So I'll have to take also continuous. Okay. Remember that if you choose the continuous, the slab width is activated. Okay. If you want to change it, you can change it as I showed you. Then let's draw. You have to start the strip outside of the boundary of the slab. Okay, so I'll pick this point, left click, drag your mouse to the right by holding control key on your keyboard in order that the strip is drawn as parallel to the x direction. Okay, then click the second. If I try to zoom in, now you see this our strip named as x1, as we have named here. The type of the strip is analytical. You remember I have set the boundary conditions. Okay, then it automatically gives the rebars. Okay, the top rebars and the bottom rebars. Okay, those rebars are coming from the analysis and design for the building analysis, because we are using analytical strip, and in analysis I have already performed the building analysis. Okay, so remember that you may change the extension of these top rebars, because our slabs are continuous, so it must not end here in the beam. So if you wanted to extend these top rebars, remember you have to use the slab width. In order to do so, at the start, I want to extend my top rebars. Okay, so I have to come here at the slab width at the start, click, and make sure that the numbers become red, and then click the next slab label. Okay, if I click on this slab, check here, the value have been changed. So the software calculate automatically this value based on the span of the next slab. Okay, then after doing so, remember, in order to see the change, you have to click on update. So if I click on update, you will see automatically the change. The extension of these rebars will be updated. Okay, then check. If I click on update, now you see the extension of the rebars have been extended. Okay, if I wanted to do so on the other side, I have to click on the end side, select the slab, then update. It will also be extended. Okay, yeah, that's how you can use the slab width to extend the top rebars. I can also put it back the way it was. If I don't want this extension, I come here, just tap 0, then click on update, and they will be ending in the slab supports. Okay, that's it for the analytical strip. So let's see for the finite element strip. Okay, if I click on finite element strip, okay, let me start modeling slab strip. Remember here, then this was 1, then the other one will be 2. Okay, then I'm choosing the finite element strip. Okay, after choosing the finite element strip, I have to choose whether it is I will be using the span strip or the fixed band strip. Okay, for our case, let's do it for this slab. For our case, I will be using the span strip. Remember, the span strip are used when your slab are bounded by beams, support beams, while here are used when you have a flat slab. For our case, we have supports, so we'll be using span strip. Then I'll have to choose the building result source. For my case, I will be using the finite element flow analysis, as I have already performed the FEE flow analysis. Okay. Then the boundary condition for my slab at the start, because I will be using the X direction. Remember, I have to start from the left to the right. So the boundary condition will be end at the left and end at the right. Okay. Then draw my strip. First click, remember to hold the control key on your keyboard. Second click, and then there will be a strip named X2 as it is here, and it is a finite element strip. Okay, that's it. It will also have rebars. Let's see, rebars. If I had a flat slab, also I may choose a finite element strip using a fixed band strip. Okay. So let's see an example of a fixed band strip, but for our case it will be for demonstration because we don't have a flat slab, which means that this finite element with fixed band strip is not applicable. So it will be for just a demonstration if you had a case of a flat slab. Okay. Come in the modeling slab strip, in the type choose this the finite element strip, then choose the fixed band strip. Okay, and then start. You have also to choose the analysis result source. Remember, for my case it is the finite flow analysis. Then for the finite element strip with fixed band, remember that I have told you that the boundary condition are not applicable. As you can see here, it is not active. Then start drawing from left to the right. Okay, left, hold down the control key on your keyboard, then click. As you can see, there will be another strip named X3. It is a finite element strip with a certain width. Okay, remember that the scope width is the property that helps us to define this width of the strip. Okay, so at the left we have 1 meter, which is 1000 mm. Okay, and at the right, if I had to change this width, for instance, at the left, let's say 2000, which means 2 meter. If I click on update, you see that our width of the strip have been updated. Okay, so this is just for demonstration because it is not applicable. So I will delete this strip. Just select it, right click, and then delete. Okay. So the last type of the strip we are going to see is the manual strip. Let's this time use the Y direction. Okay, and the number will be 1. Let's take an example of this meter slab. So then the type I will be choosing the manual strip. Okay, again the boundary condition, slab width, and the scope of the width, it is not applicable. move to the steel bar tabs, and then I have to choose or to feed all these parameters for the top steel and the bottom steel. Choose whether you want to have the bob at the left or the right, the left extension, the right extension, the quantity of the steel bars, and even the diameter of steel bars. This you can choose. And you can also put in the value of the spacing between steel bars. Okay. So let's, for instance, say I want bobs only for the bottom steel. I want to use a diameter of 8 and the spacing of 250 mm. Okay, after setting all the parameter, so I have to draw these strips. Okay. So remember that in the y direction, or vertical strips, you have to draw from the top to from the bottom to the top. Okay. So I will first click on the bottom, then remember to hold the Control key on your keyboard, then click for the second. So as you can see, there are manual strip named Y1, as we have here named Y1. Okay, with all the reinforcement. Okay. So that's it. It's up to you as a user, as a designer, to know which type of the strip we'll be using, either the analytical strip, finite element strip, or the manual strips. Then choose the boundary condition, slab width, scope width, whether it is applicable or not, and then draw or model your strip in the model. Okay, coming to the conclusion, remember that even after drawing the strip, you can always edit or modify it by clicking it and right click, going to properties. You can always change the label, the type, the boundary, and then update. Okay. For the manual strip, you can even update these rebars. Left click in properties, in steel bars. For instance, if I previously have used a diameter of 8, for instance, let's say I want to use a diameter of 10, click on update, and you see that they have been updated. Okay, so Protastructure is very flexible, and you can always modify and make a change to the strips. Okay, so that's it for today. Thank you for watching, and I hope this video was helpful.